Hello, everyone. Welcome and thank you for joining our webinar where you'll learn how Maxwell Health protects its MongoDB workloads on Amazon Web Services. My name is Doug Klisch. I'm a solutions architect at Amazon Web Services, specifically working with our partners, one of which today is Rubrik Datos, that's here to help us learn how we're doing this. Just a little housekeeping. When you joined today, you chose which audio method you would use to come in, whether it's through your computer or through a phone call. You can change that at any time from the audio control panel if you're having an issue with that audio feed. There's just a radio button there to choose between computer audio and phone call. From that control panel, you also have the opportunity to submit questions for today's presentation. You just type your question into the box in the question panel. We'll collect all the questions and address as many as we can during the Q&A session at the end of today's presentation. Also at the end is a brief survey. Please stay connected until the end of the broadcast and submit your feedback, as opinions really do count. Lastly, we will have the presentation available through SlideShare, along with a recording of this webinar on YouTube. An email will be sent out about 2 to 3 days after the conclusion of the event, so keep an eye out to the follow-up email address that you provided to us. Again, welcome and thank you for coming in and listening to us today. We know it's really hard to take this amount of time out of your day, and we really appreciate you for coming in and listening to it and going through everything with us. Today for speakers, we have myself, Doug Klisch, Solutions Architect at AWS, Tarun Thakur, General Manager of Rubrik Datos IO, and Brian Diet, the Director of Engineering at Maxwell Health. And Maxwell Health is the customer case study that we'll go over today. For today's agenda, we'll cover the basics of backup and recovery on AWS, just lay down some groundwork there. Tarun will come in and talk about Rubrik Datos IO, RecoverX, and how that kind of puts together the building blocks we provide and provides a better end-to-end solution for our customers. And then a case study from Brian from Maxwell Health. And then we'll go through the QA that we talked about earlier. And like I said, remember to put questions in the box over there, so we'll have some stuff to go over for you guys. For learning objectives, we'll talk about protecting MongoDB workloads in AWS using an application-consistent backup solution. We'll learn about quickly restoring backups from any point in time for testing and development, achieving fast recovery time objective with granular search and recovery, and how to improve backup storage efficiency, allowing for affordable long-term backup retention. So to get us started off, like I said, I'll cover some backup and recovery on AWS. We have a lot of great building blocks that help you back up your on-prem workloads or your cloud workloads to different parts of AWS, and a lot of great areas to start off with there. One of the places that I generally like to start is talking about our global infrastructure. Those who are new to AWS may just be operating in one region that's close to you and not realize what's there. Those who don't currently use AWS today might not know what we have available. At this point, we have 18 regions available across the globe. And when I say region, I mean a completely geographically separate data center campus area. When I'm talking about something like the East Coast of the US, the West Coast of the US, Sydney, Australia, Dublin, Bahrain coming online soon, things like that. In this slide, you'll see little numbers in those dots, and those numbers represent how many availability zones exist in the region. At AWS, we call an availability zone basically a separate data center campus that's on a different power grid in a different floodplain, tied into different communications infrastructure, all of that fun stuff, so that we have a lot of redundancy within those regions. And a simple, normal natural disaster, tornadoes, things like that, shouldn't be able to affect more than one availability zone at a time. The availability zones are close enough that we're able to do synchronous replication between them, so you're able to operate your workloads in a redundant manner within a region, but then also use other regions throughout the globe to back that up in case of a massive failure. We all know how backup and recovery worked before the cloud. You had your app servers, a media server connected to them, back things up to some tape or local disk on-prem. Some guy came by in a truck and picked those up, brought them off to a tape bunker somewhere. And when you needed them, you had to make a phone call or submit a ticket, get a tape pulled out of a vault, had to come back by a truck to where you needed it. The process was slow, and there was a lot of issues that could happen on the way. That truck gets into an accident, tapes are lost, things like that. With the cloud, we're able to short circuit that a little bit and take away a lot of the risk, as well as allow for a lot more efficient and quick restores and data transmit out. Basically, you can use the same type of infrastructure where your media server still backs up your application servers. A lot of the times you can still use the same media servers. It can still keep those local disk copies, but you can either use a cloud gateway or have a media server that connects directly out to AWS, either over the internet using HTTPS to keep it encrypted and secure, over an AWS Direct Connect link or a VPN if you need a little bit more security or more predictable latency, and come into our AWS services to store data. We have some building block services there that we're showing that you go to. We'll touch a little bit on this next slide. Usually on the right side are the services that everybody's a little more familiar with Amazon S3 and Amazon Glacier. S3 being our object store for our hotter data, Glacier being our archive storage. We also have our Amazon Elastic Block Storage that's used for EC2 instances stores, and the ephemeral storage on our EC2 instances. We have a newer service with the Amazon Elastic File System that is our file-based storage for NFS connections. And we have a ton of different ways to get that data in, whether we're using AWS Snowball and actually shipping data in, using Direct Connect with direct fiber to our facilities, or one of the things we'll talk about today is our ISV connectors that allow you to more seamlessly take your data from your applications, store it in these services, and not have to worry as much about how to get it there and having to deal with setting that up, scripting it, and things like that. One of the things at AWS that we concentrate on is making sure that we're able to provide value in everything that you do. And a good point in this slide is value in every gigabit or gigabyte. You're able to scale whatever you need. If you start off with 2 gigs of data, you can go up to terabytes or petabytes of data. Scale is one of the big things. Durability, services like S3 have 11 nines of durability. Objects aren't lost regularly. They're available for that in each region. S3 also has options for availability zone durability. We'll talk about that a little bit later. You can also use your backups for cloud data migration. If you're already backing up to the cloud, it's really easy to restore to the cloud. We have lifecycle management options to allow you to have data go through different tiers of storage or even delete out once it's hit its max lifecycle. And there's a broad integration with all of our other AWS services once that data is there in services like S3. One of the big things to realize is that when you're buying storage on-prem, you have to budget that storage and try to think about what your users are going to want for the duration of your budget period. If it's the beginning of the year and you buy all of your storage for the entire year, you estimate that, hey, I need about 800 terabytes of storage, so you go and buy a petabyte of raw storage. You then allocate that storage out, reducing how much storage is usable again, and then you find that, hey, your applications are actually using about 400 terabytes of application data, and you're paying for that upfront. You're paying for it all year, whether you use it or not. With our Amazon storage offerings, you're just using that little slice of what you're using right now. When you need to scale up to that petabyte, the disk is already there. You weren't paying for it. We just had it there in reserve for all of our customers to use. And if you need to scale past what you purchased, there's no issue with having to go add more hardware, wait for vendors to arrive, things like that. Just continue to use it, continue to add data, grow above what you estimated, and that data is available, the storage space is available for you. You're able to use it as much as you want. Really allows that flexibility in your IT budgeting and keeps all the finance people happy that you're most efficiently utilizing the money and the resources that are available to you. One thing that we'll touch on real quick is the innovation for Amazon S3. Over the past year or two, we've had a lot of things change in S3 that have made it a lot more usable and economical for our enterprise use cases and for our application load use cases. One of the new things is event notifications. So when you store an item into an S3 bucket, an event is fired off to different services within AWS to allow processing. A great example of this is if you have images that have to be either filtered or sorted, resized, like that. A user uploads an image to an S3 bucket, a Lambda job kicks off, runs all the scripts that you need on it, places it wherever it needs to go, and then handles either deleting or moving that image out of the bucket. That way you don't have to have a system sitting in place waiting for users to upload things, polling queues and things like that. It's all event-based. We also now have cross-region replication, where you're able to place an item in an S3 bucket in US East, for instance, and have that bucket replicated to Dublin or anywhere else in our S3 footprint. Users ask for that a lot because when they're wanting to store across the globe, they were having to set up that and script it, so that was something that we could put in place to help them out. We also have a VPC endpoint for Amazon S3, which one of the things that we're asked all the time is, how do we keep all of this data secure? We can't have it in a public cloud and publicly accessible. When you're working with Amazon Web Services, all of your resources for EC2, things like Amazon Redshift, et cetera, exist within a virtual private cloud that you control the network access to, you control the IP address scheming. By default, it's all private RFC 1918 addressing. And so one of the issues that we had previously was that when you needed to access data out of S3, you had to go out over the private edge of our network and connect to the S3 endpoints. We now have those VPC endpoints, so you're able to do all that within your own internal VPC, and the traffic never leaves the VPC. We also have a lot of great CloudWalk metrics in place now. We're able to see what's going on inside of S3, see how your data is being used, where your billing's coming from, things like that. Really great way to allow both administrators and auditors to keep an eye on what's going on in the storage. We've also constantly upgraded the S3 bucket limit, so you're able to have more buckets, store more objects, and things like that. We also now have read after write consistency in all regions. So in every S3 region that we have, as soon as you write an object and you get that 200 back, you're able to instantly read against it. There's no waiting for that to push out across the entire region before you're able to see what's there. Kind of two features in one. Last year we introduced S3 standard infrequent access storage, which is a lower price storage tier in S3 where you get charged less for data that's stored in it, but you get charged more if you need to access that data. So it's for that kind of cold data that you don't need often, but when you need it quick. In addition to that, earlier this year we released Amazon S3 One Zone IA, which is what I referred to earlier. S3 is a region-wide service by default. If you launch it in US East, it will use multiple availability zones within US East to protect that data. S3 One Zone is a great solution for second copy data or third copy data where you just need another copy of it somewhere. You already have an authoritative source for it. And so for an even lower price, you store an S3 One Zone, and it does exactly what it says. It stores it in one availability zone within the region. So within that single availability zone, it still has 11 nines of durability, but it is stored only in one availability zone. So there's some trade-offs there, but it's a great low-cost solution for second copy data. Within lifecycle policy, we now have expired object delete markers, so you can expire objects out, delete them out, and incomplete multi-part upload expiration, so that when you have multi-part uploads that never finish out, they're able to be deleted off automatically. A great additional feature is Amazon S3 transfer acceleration, which allows you to utilize all of our CD endpoints around the world with over 100 locations to get data back to those individual regions. So if you have users that aren't close to one of our regions, they're still able to utilize the Amazon backbone and connect back to those regions faster than if they used the public internet. Within S3, we touched on it a little bit, but it's great to kind of break out what each class of S3 storage is and what you would use it for. So Amazon S3 standard is used for active data, the data that's being used actively by an application or actively by your users on a daily, minutely, second basis. Our two infrequently accessed products, being standard IA and One Zone IA, are for that infrequently accessed data that, like I said before, you may not need it all the time, but when you need it now. We also have Amazon Glacier, which is for archive data. With Glacier, there are a lot of costs for getting the data out, depending on the size of the data, and it isn't an instant access. We do have quicker recoveries with expedited to 3 to 5 minute recovery at this point, but it's not great for an application that needs instant access to a data or with timeout waiting for a file handle. It's great for your archive storage, for compliance data, things like that. This kind of explains and groups together how you'd use it and how you'd use your life cycles with that. You're hot for active and temporary data with stick in S3. It shares a common namespace and shares all of our security, event notifications, versioning, and cross-region replication with S3IA. So you're able to easily move back and forth between those, access them through a common API, and use it as you need. There will just be more charge when you use that IA data. However, when you lifecycle it down to Glacier, that is cold, and it does have to be pulled back into S3IA or S3 before you're able to access it by your application. So now we'll move on to Tarun, who's going to talk to us about Rubrik Datos IO or RecoverX. Take it away, Tarun.
Cool. Thank you very much, Doug. Good morning, everyone. Thank you for joining, and thank you for making the time. As Doug mentioned, we truly value the time that you're making for this webinar. We know this doesn't come easy, so thank you very much. I'm looking forward to taking you through the next few slides on what we built with Datos and give you a deep dive into our product RecoverX for NoSQL databases, one of them being MongoDB. So with that, we'll get started. As always, please feel free to leave any questions on the chat window as you feel like. Just to sort of set the stage here, and sort of why, it's important to understand the why before we talk about the what and the how. And essentially, the observation we have had in the market with, working with customers like yourself and organizations like yourself is that pretty much everybody is experiencing top 3 macro forces of digital transformation, a customer experience, and leveraging these elastic resources of cloud to really achieve the business objectives, right? And so, as we look at, as sort of the organizations look towards those macro movements of digital transformation and customer 360-degree experience, it has resulted in this massive growth of what we call as cloud-born or cloud-native applications of, examples being security analytics or Internet of Things or e-commerce or SaaS. And even if you look towards the next generation of these applications with AI, with ML, or even blockchain, right? Pretty much every organization is building these applications on top of distributed architectures, which is sort of what we call them, a class of shared nothing distributed architectures as NoSQL databases. They're also referred to as non-relational databases, and on the similar sort of vein, we sort of also refer or target these applications on distributed analytical data stores like like the class of Hadoop, right? So what we observe and what we've observed over the last 4 years that we've been at this path is majority of these applications and the deployments of these NoSQL databases like MongoDB begins with public cloud in mind and heart, right? However, that said, when we do see our customers that we work with and organizations we interface with, very quickly the realization of multi-cloud comes to being, where hey, I want to run my some very critical use cases on-prem still. On-prem is still a massive driver, but I want to move all the application elastic use cases to the cloud and maybe DR to a different cloud, right? So we see a very prominent force towards both a hybrid cloud, multi-cloud, public cloud, as well as moving these use cases and moving this data around multi-cloud environments. So that's that's the nature of the why. And then an obvious question that we get very quickly is that cloud is sort of highly resilient, highly available, 9 nines, as Doug sort of took us deeper into that technology, and that's absolutely true, right? And however, if you look very specifically into distributed architectures like NoSQL, while the failures of media and network can be addressed very efficiently and in a highly performant way to address the challenges of high availability, the native replication addresses that. However, when it comes to a very business critical use cases or needs, such as protecting against logical corruption, or also so as called as fat fingers, or some admin accidentally deleted a table. A majority of the $20 billion being spent in the backup industry is being spent to cover things like logical corruption and to protect against those what if scenarios. And number three that we sort of hear very often is this whole mobility use case also can be dubbed as test data management use case in the cloud, right? The ability to spin up clusters in the cloud from a subset of your historical data. So, essentially for number two and number three use case, you need a very robust enterprise-grade multi-platform backup and recovery platform. A backup and recovery is not, as Doug mentioned, it's not something a new technology. It has been there for 20 plus years. However, with cloud and the elastic nature and the distributed nature of the infrastructure underneath, you have to think about backup and recovery in a very unique and a different way. So, specifically for Mongo, the native replication addresses the use case of media network failures or the needs of dealing with media failures. And Mongo of course offers native utilities, whether it be Mongo Dump or even branded products like Ops Manager or Cloud Manager to give you or address the needs of backup. However, what we really have heard from our customers and from organizations like yourself is they're really looking to address a heavy hammer of Ops Manager around TCO, around backups for sharded clusters where consistency comes to being, the complex nature of the deployment. Again, the cloud is all about giving you simplicity and simplicity of orchestration, deployment, and management, and the tools around that should also follow those principles. And then of course you back up to recover, right? And recovery at scale is a very, very big challenge from what we hear with Ops Manager, and we look to solve these core 4 or 5 problems with Rubrik Datos. And so just to give you a little bit deeper perspective onto the customer requirements and challenges that we hear. Number one, as I said, backup, and we're living in the world of big data. We're living in the world of high volume, high velocity. And now we're not talking about an average database could be a terabyte or an average table that could be 10 gig or 20 gig. We're talking about environments where a MongoDB database could be north of 100 nodes or north of 20, 40 nodes spread across either replica sets or sharded databases, right? Or collections which are sharded across multiple nodes. And in that environment, not only are you not dealing with application consistent backup for that scale, we have customers who have about 5,000 tables within a single replica set, and we have customers who have a 100 plus node sharded cluster with a single table being north of 20 terabytes, right? So doing consistent backups at that scale is a very hard problem, but we hear that as number one. Number two, when it comes to restore, as Doug said, when you need it now. We hear requirements of about a terabyte restore in less than 4 hours, and be able to build up an architecture to address that fast restore speeds is at the heart of what we have done. And number three, as I said, of course we want to restore the data back on the production database. That's really key use case, or the primary use case. But we hear a lot of our customers asking for a use case where, hey, I have a production database of, let's say, 9 node, could be a 3 by 3, a single replica set 1 by 3, but I want to restore that from a 3 replica set or a sharded MongoDB database to a single replica set, right? Restoring the data between these alternate topologies is a very, very key critical use case, and we've built, and I'll talk about the technology that we have built to address these. And number four, we're all dealing with, as you move the data to the cloud, this shouldn't mean that we don't worry about protection, shouldn't we worry that we not worry about security hacks. And we're all dealing with the world of ransomware compliance, but as well as very strict requirements around GDPR, right? Essentially relating to table level or granular backups. And then finally, as I said, let's not, we move to the cloud. There has to be not only about simplicity and onboarding and orchestration, but it also has to impact the bottom line by giving you a very efficient TCO solution. And the cost of deployment and the cost of running it operationally on a day-to-day is at the heart of the problem, or the value that we want to deliver, so that you experience a high ROI or experience a high, a very low TCO for when you go and scale these applications on MongoDB. In terms of use cases from those challenges, we're talking about point-in-time backup and going one step beyond with any point in time, maybe ability to go back even a minute or go back to a few minutes. Number two, test and refresh, alternate topology data movement. And of course, this whole use case of mobility where I wanted to run on Amazon Cloud, but I may want to bring that data back or bring data portability as a use case back to on-prem for really my compliance and governance use cases. So what we have built is this product called RecoverX. It's an offering as part of the Datos IO business unit within Rubrik. And really sort of the three drivers, the product itself is a scale-out software. It can be deployed on as simple as an 8 CPU, 632 GB M4 instance on an EC2 instance of Amazon, and can simply store your backups on S3. We really don't need EBS, and really sort of save you that cloud storage cost of very high block storage. And sort of the three value or sort of the three key elements of the product are rooted in the following. Number one, the whole application consistency at scale, right? We're in the business of providing you a durable backup copy, and durable backup copy for sharded clusters is a problem that we have solved with Datos IO. Not only just for Mongo, we scale it across platforms, so it could be Cassandra. Those are the two NoSQL databases we support today on Amazon, and we're looking to support some of the advanced, some of the next generation NoSQL or cloud native databases like DynamoDB in our roadmap. So that's number one, protect your NoSQL applications no matter which NoSQL database. And most often we see people using different flavors of NoSQL databases. Number two is, if you're going to operate in the cloud, let's not take on-prem software and call it cloud. You have to truly be rooted in principles of elasticity, right? And so with Datos, you have a scale-out RecoverX product. You can start with a single node, scale it to 3 nodes, or scale it to 5 nodes, and vice versa. And it's simply as provisioning, as your application growth increases, sort of setting up more RecoverX nodes to handle that high change rate, handle that high table count, or handle that highly sharded database set. And number three, storage savings at scale, right? Again, we want to be part of your journey towards the cloud. You've already made that decision with cloud-born applications and with MongoDB databases. Now is the time to start protecting them for those reasons that we discussed earlier. But at the heart, we don't want to be overly TCO burden. Rather, we want to sort of come around and put together a product, a solution offering that gives you a simple solution to manage a single EC2 instance or 3-node EC2 instance if that's what your workload demands, and a simple, cost-effective S3 storage, right? We don't want to bring around elements like EBS and others, which could increase your cloud cost significantly. So that's the key, and sort of on the broad macro points of Datos IO. Taking a dive deeper on how it looks when it is deployed, we call it a reference diagram or a reference architecture. And what you're really seeing here is, we sort of cover this in two sections. Number one, what are the key elements of reference deployment? Number one is, of course, your MongoDB database deployed equally on similar EC2 instances. On the left, what you see is a multiple replica set 1 by 3 each as a cluster one. We call it a data source. Number two is your secondary storage, backup storage. In this case, it's an S3 object storage, again elastic in nature. And number three, right? And that RecoverX software is very simply running, as I said, on EC2 instance. We don't need media servers. We don't need this whole management of backup software that you may have experienced with some of the legacy and traditional backup software providers, right? And number four is really you may not, if that's a use case where a cluster 2 is a simple 1 by 3 replica set, which could be provisioned as a pre-prod, as a test dev cluster for your application use cases. So essentially, that's the one part, very simple 3-part deployment. In terms of RecoverX and the orchestration and the control plane nature of RecoverX, we as part of the deployment, it's all a fully RESTful API product. So the number one API, the first one is an add source, which simply configures your MongoDB under the protection scheme of RecoverX, right? So think of it, you're provisioning you provisioned the EC2 instance where you're going to deploy RecoverX. You need to have RecoverX be able to talk to your MongoDB database. Now we stay at a very simple APIs. We are tailing op logs. We are not going deeper than that and going deeper into MongoDB database. So all we need is a MongoDB instance, and we'll tail op logs. That's all really we need to do. And we do that with these very lightweight application listeners. They can be deployed on all the nodes of MongoDB, or you can choose to say, hey, some customers don't want us to touch their primary nodes and only deploy them on secondaries, and that's fine as well. From their point on every RP or every backup interval, it's a very simple job of application listeners to tail those op logs, right? Now, the good news is that we are tailing those op logs all the time, so think of it as a truly continuous protection. And we're steering those op logs on the S3 storage, and once they have landed in a very parallel streaming fashion, we take those op logs and apply the secret sauce of RecoverX to convert them into a consistent plus dedupe that data down into a single copy rather than storing the 3 replicas that you have on the source, right? Remember, NoSQL databases, every write is triple replicated. In this case, if you write a data to primary, dependent on how your consistency settings are set with applications, you could either have a quorum or an all or just one. We see majority of our customers with either all or quorum, which is, you land the data to primary, you're going to wait for it to land to secondary before the application realizes that acknowledgement, right? And so that nature of distributed writes or multiple replica writes shouldn't mean that on the backup storage also we have to store all those multiple copies, right? And then on the recovery path, which we have defined as a time travel in a spirit of time machine, you can simply go to a time travel, pick a collection. Again, on a protection side, you could protect either an entire database or collections within a database. You have both either of those choices. And if you're protecting a database, you could restore an individual collection, right? That's the granular nature I'm talking about for the use cases of compliance or GDPR or ransomware. And not only could you not restore that column family back to the cluster 1 in this example, but we also have built a ton of orchestration to restore that single collection to an alternate topology of 1 by 3. The product can be accessed finally through a classical CLI. Of course, we expect, or our goal is customers never get to CLI and leverage a world-class consumer grade UI and also a fully RESTful APIs that you can tie them into some of your own tools that you may be using, like Grafana, like Datadog, or other tools in the cloud, even like a Splunk, right? That's the sort of a reference architecture. Again, we've tried to keep it very simplistic, and we've sort of hid and worked very hard over the last 4 years to hide that complexity underneath the RecoverX product. In terms of sort of the features, some of the features and some of the sort of value associated with those features, as I said, you could do backups of entire databases, or you could do of an individual collection. We support 3.2, 3.4, 3.6, any of those versions of MongoDB. We're going to store those backups in native formats. What I mean by that, it's a very critical point because it's your data. It may be today on Amazon Cloud, or tomorrow it may be on private cloud. It's your data, and so you should have the control and the visibility into that data. So we always store MongoDB backups in native formats, meaning they'll always be in wire tiger formats. So essentially, you could go to your S3 bucket, you could do a list, and you could see all your wire tiger files just as they were meant to be on the source. Now, you'll need the RecoverX software to stitch them together for restores, but those backups are always available in native formats. Similarly, on the recovery path, you could restore an entire database, you could restore an individual collection, and not only could you not restore at a fixed point in time, but you could also restore to any point in time. In many cases, we see customers want to, the oops moment has happened, the RPO interval of probably perhaps 4 hours was not enough, and you want to go, between any point in time between those 4 hours, right? So that's number one. Number two is as I said, we want to stay true to the spirit of cloud with elasticity and with reducing the operational pain and the management pain, right? So we're not going to force you down path of any media servers. Storage cost will be simply S3, where a single backup is of course a first full, but from there on it's all incremental forever. And not only that, but we'll only restore if we are tailing op logs from all the three, primary, secondary, we are going to apply our deduplication technology and store only a single backup copy, right? And if there's interest, we will love to engage, and we'll show you with proven TCO studies that our savings that we can drive back for your MongoDB backup is north of 70%, even towards 80% that we see when compared with some of the native MongoDB Ops Manager-like solutions. And number three is development efficiencies. I called about this use case portability and mobility. At the heart, or from a technology mindset, it really means test data management use case. We already sort of talked about that. There we are trying to build things like restore fast. Restore meaning the ability to pull the data as fast as you can from S3, the ability to flood the network pipe, and be able to go as fast as Mongo will allow you to without any throttle, without any bottlenecks in the restore data movement, right? So we achieved that with an architecture, with a media serverless architecture. And then finally, be able to restore to alternate topology. We're looking for a next step. And some of the organizations ask me this question: hey, not only can you not restore the data, but could you also spin up MongoDB clusters on the fly? Very, very exciting use case, but a very hard to build, or something that we're exploring that on the restore. You just point us a version, and we'll not only restore that data back, but we'll also spin up an EC2 instance on top of that for you. So again, completely orchestrating that path. And that's pretty much the end of my section. I wanted to introduce Brian from Maxwell Health. Brian is Director of Engineering. Very thankful and very grateful for Brian to make this time to speak about their use case with Datos, their applicability of MongoDB in their environment, and Maxwell Health has been a long successful customer, and we're again very thankful and grateful for Brian to join and share his perspective. Brian, over to you.
Great, thanks, Tarun. Hi, everyone. Very happy to be here today and tell you a little bit more about how we're using RecoverX here at Maxwell Health. So first off, to start, I just wanted to tell you just a short bit about Maxwell Health and what we do here. So Maxwell Health is a company focused on benefits and HR for small to medium-sized employers. So what that means is really when you go for open enrollment, when you start at a new company, when you have any kind of life-changing event. In the past, often that was done with pen and paper, but more and more that is being done with software like what Maxwell Health provides. So this is software both for the employee who's signing things up, the employer, as well as the brokers who also work within this business. There's a lot of data, a lot of complications with the benefits business, and a lot of things that we have to follow in terms of compliance. So a lot of things that we have to think about here, all within AWS of where we're storing it. And this is something that we'll talk about a little bit here. We do use at Maxwell Health Mongo for some of our data storage. We are also actually using RDS and Aurora within AWS. For those solutions using RDS, that is something where the backups are taken care of for us. So that's part of that AWS setup. Works great for us. Haven't had any issues with that. On the Mongo side, that is something that when we started using it, we really had to hand roll our solution. That's what we found we had to do. Really had to be careful with it because of the business we're in, but really finding that there was a lot of data for us to get through. So you can see here that we're storing 11 terabytes worth of data daily, just a lot of data that we're storing here, and a lot of things that we have to back up. So as you can see, this kind of usage just isn't sustainable. We could kind of extrapolate out where this storage cost would be, and it wasn't looking like this was really something we wanted to go down the path we're on. We could see that the path for our SLAs was not good. If we continue down this, just based on our usage, that we would have a problem in the future. Another thing that we were having an issue with was we did have a case where we really wanted to just grab one collection. And instead of that, the solution we had to grab full databases, all of the information, just not the kind of data recovery solution we wanted to have. And last issue we're seeing was, this is a bit related to those growth concerns, was we do have a staging environment here, which is pretty close, taking some information out, but a pretty close replication of our production environment. And that copy down happens every night. And it was starting to get into the morning hours, was taking too long. So that was a concern as well. So we looked around and tried to see what different offerings and what we could potentially do ourselves there. And in the end, we moved away from even considering the idea of doing more ourselves. So we wanted to focus on our own business. We're happy to use different vendors, whether it's RecoverX, AWS, or others, to handle the non-core parts of our business. We're also looking for a solution that did incremental backups. The way we were doing things, where it was a full backup every hour, was clearly not sustainable. So we needed some way that it was going to deduplicate data or otherwise take care of the data in a way where we could back up as much as we need to while not storing that full backup. We liked that we could, it was being stored on S3, which then we could store some on Glacier. And we also liked that it was within our own AWS account. So these points are just, for us, we're very AWS focused, and fitting within that framework was a big plus to us. It's also a plus to us because we are bound by HIPAA regulations. And everything that we're using within here fits within those within that framework. And last bit is, like I mentioned earlier, we really wanted the kind of collection database, smaller level recovering of data, and doing that and searching through that was simple within RecoverX. One of the last things I want to talk about here is just giving a pretty good overview of how it all flows through. This isn't meant to show all of how we use Mongo, certainly not all of how we use all of our setup here at Maxwell Health, but I just wanted to give a really small snapshot of our usage of RecoverX. So RecoverX is this EC2 instance within our account that we are using to get information from our MongoDB replica set. We have a 3-member replica set in production, and it's continuously getting that information from different collections and databases, doing its own magic and storing that in S3. Sometimes we do ship that information to Glacier, but in any case, the other part that we're really doing on a daily basis is also sending that information to a staging replica set. Now, Drew mentioned trying to make sure people don't have to use the CLI, and this is the one case we do. We do have kind of a unusual case here, but we do have a cron set up, which is then using the CLI to clear out. So we clear out ourselves that staging replica set, and then we use the CLI to copy information afresh each day. So an interesting bit about that is that we are essentially testing out RecoverX every day. We are reusing our backups every day, and it's working great. So that is kind of an inbuilt mechanism we have to really see how quick and how good RecoverX can work. One bit I didn't show here, one more thing that's really a part of this, is sometimes we actually also do snapshots that staging replica set, we do this as just another restore point. We're very, we just want to make sure we have as many restore points as possible, and it fits really well into this setup. Just having that kind of our own script that runs and using the staging replica set as another place of using recovery for us. So where are we after using RecoverX? We have simpler backup and recovery SLAs. It's not something we're considering anymore. I also mentioned in here that recovery time, part of those SLAs, we can see that those are reduced. So because we're doing that staging, that staging recovery time or that staging copy, we can see every day what that potential recovery time would be and see that it is something that works for us. Another item is that storage cost has gone down drastically. What we were storing before was a lot for each day, and that has gone down. I don't remember the exact percentage, 95, 99%, somewhere within there. You can see the numbers. We saw a very drastic reduction there. And one more thing that we weren't actually looking for, but that we got, which is the UI is easy to use. It's a very simple UI. We have no problem going in there and changing things as we need to. And that is it for me. Thank you.
Awesome. Thank you, Brian and Tarun. It's all really great to see how the partner solution is able to really tie in all the features and help deliver something easy to use to the customers. We'll start here with Q&A. I get an easy one that just came through the chat, and we'll rotate through to everybody here. Great question is, was asked, I spent a lot of time talking about S3 and kind of brushed over EBS. And the question was, is EBS pay-as-you-go as well, or does it only apply to S3 and Glacier? So EBS is pay-as-you-go in the form of you don't have to do like on-prem and think of all the storage that you'll need to use throughout the time. However, you pay for what you provision. So if you provision a volume that uses 55 gigs, you'll be billed for 55 gigs from when that volume is provisioned. However, you can start with a medium kind of size volume, resize that volume as you need, or add additional volumes to an EC2 instance, but you are paying for provision capacity. And I'll also shoot the link over into the chat about the pricing page for that. Over to Tarun. We talked a lot about Mongo, but what other NoSQL databases does Rubrik Datos IO support?
Great question, Doug. Thank you so much. So folks, we support today two NoSQL databases, MongoDB and Cassandra. Cassandra could be either the open source Apache Cassandra version or DataStax, and we support all the way to DataStax 5.1.7, which is open source 3.11. Those are the two we support today, and we're looking at a bunch of other NoSQL databases as a roadmap for second half of this year towards next year. Things like Amazon DynamoDB, things like Couchbase, and others. So, if any of those are in your environment or you look towards them, love to connect.
Awesome, thank you, Tarun. Brian, how exactly does Maxwell Health copy data to their staging environments?
Yeah, so I can tell you a little bit more about that. So that kind of script that I'd mentioned that we wrote and we use, that is really just a pretty simple shell cron that we run on the server, and within there, all we are doing is we are completely removing the collections and databases from the staging server. So we are connecting to that directly from one server to another, and making sure that that is as clean, wiped fresh, so that we have some place that we can do that restore. Then after that, what we're doing is we're going through and getting all the collections for each of the databases we're interested in, and really easily able to, with one line from the CLI, call a number of parameters we add to that. But what it's doing is saying we have one server here, the production server. Grab its last restore information you have, and take that and that collection and put it onto this other server that you know about. And with that one line, we're able to take each collection and restore it properly.
Awesome, thank you. Another good one here for me. So we've mentioned of S3 transfer acceleration. What is the additional cost for that? It's actually a great point. It's kind of one of my favorite additions to S3 because of how it works. So in the benefit being that if you're transmitting data over the public internet, it's kind of unpredictable and you're at the mercy of routing and least costs and whatever happens there. With transfer acceleration, we haul it over our private backbone instead of going over the public internet from the edge pop, and we charge if we perceived that we actually did speed up the transfer. So if the system looks at it and determines that over the public internet there would have been the same delay that we had over our backbone, we actually don't charge the customer for it at all. So it's only charged if it actually did speed it up, and there is a different charge in the event that it was able to assist you with that. Looks like we have it back to Tarun with, and hey, I think I'd ask this question. Does Rubrik Datos IO support AWS DynamoDB? If not, when will it?
Great question. Doug. We get that often. Again, one of the early principles, we wanted to build an architecture which could scale across platforms, not just for one or two, but Mongo, Cassandra, Couch, and others. So DynamoDB is good news and bad news. Good news is we already have prototyped the solution within our engineering labs, and currently it is scheduled for more second half of next year. But again, I'm not sure how many of you folks know about Rubrik. Rubrik is squarely and centrally focused on customer feedback, and we take the feedback very seriously to help innovate our roadmap. And love to engage with customers who or organizations who are using DynamoDB, and I love to make sure that the path we're headed down is the right path. But right now it's planned for second half of next year.
Awesome, thanks. And I think that's one of the great synergies between Rubrik and AWS is where we work the same way. It's all based off of what customers ask for. So if there are features out there that customers need, definitely make sure you get them to your partners, to your reps at AWS, to whoever you're buying the different solutions for, because we all definitely care what our customers want and try to deliver that. So back over to Brian. So how does Maxwell Health manage the other types of backups, and how does it compare to what you're able to accomplish with RecoverX?
Yeah, so really the only other types of backups we're doing for databases is the RDS one I mentioned, and obviously we are backing up other types of data, but to focus on the databases, from our standpoint, both of them do exactly what we need to do, which is being able to do it on the timelines we need, having programmatic APIs to do things with it as needed, and being able to visually see what's happening as needed, and being able to alert on things if they go wrong. So those are really the core things that we need. The RDS solution does provide that for us, and the RecoverX solution provides that as well.
Awesome. Our next one actually kind of ties really well into that. So when you at Maxwell Health were looking into switching your backup plan, what other choices did you look at?
Yeah, when we were looking at it, the things we were looking at, I pretty much listed out in terms of what we wanted to do, which is really have something that wasn't have something that wasn't as large as we're having it, seeing it, something that could be faster in doing things, and something that would really not be something we're managing ourselves. When we did look around and think about it some more, I can think of some more things that RecoverX did provide for us, which is when you are doing that homegrown solution, it is tough to do some of that alerting, to do some of that, some of those logging and extra things of visually seeing what's going on. That's tougher to do with your own scripts. There's a lot more pieces there. Beyond just the keeping all of the libraries up to date and making sure it's tested well and all of that. So there's a lot of things that we were looking for essentially to not have a homegrown solution, and that we found.
Awesome. Yeah, and that's one of the great places where our partners really fit in, is to simplify those things and get that maintenance away. I mean, one of the things that we all focus on is trying to keep those workloads off of our customers and let them focus on what their business truly is, which generally isn't 100% monitoring backups. So Tarun, with Datos IO, what's the pricing model for it?
Another question, good question, sorry. So simply, we keep the Rubrik Datos pricing model for MongoDB based on your front end capacity. So, unlike MongoDB, where you may be paying for, or not maybe, but you are going to be paying for every node within the database and buying an associated MongoDB license, Datos for backup and recovery, or any other use case, test dev, alternative topology, restore, any class of those use cases, all you simply pay is based on front end capacity. So, if you are a customer who wants to protect across all your primaries and secondaries, so we'll just take the physical data size on each node and multiply that by across all your nodes. If you're a customer which is like, hey, I only want to protect my primaries, I don't want to protect my secondaries, that's fine as well. But we'll sort of give you guidance and best practices that you may be exposed to some of the data loss risk scenarios, especially when primary switches to secondaries and secondaries could switch to primaries. So, but anyways, regardless, simple answer, it's based on front end capacity based pricing. Take your physical database size and multiply that across your nodes, and that's simply pricing, and you could use internally as many RecoverX instances you need to protect that data.
Awesome. Sounds pretty simple. Another fun one for me was asked, what are the biggest issues or challenges the customers have moving data into S3? And that's kind of one of the fun ones. I mean, AWS provides a whole bunch of different ways to get data in there, but with a lot of our small business and enterprise workloads, it's a big thing of trying to move their application data or their databases, things that have been built on block-based storage, and trying to make those move into a object-based store for the cost considerations and the availability considerations. We have many ways to do it. We have trucks that we can actually roll that you can load data onto, then put it into S3. But all of it comes down to sometimes a lot of the things, like Brian was talking about, of having to write scripts to do things and maintain that. And that's really where a lot of our partner solutions like Rubrik Datos IO come in, that help integrate with your applications directly. They handle that transition from the application data stores or the block data stores, slide that into S3 in an object-friendly format, and allow you to do that in a fun, easy to use UI that you don't have to maintain, and you're not really constantly stuck behind the ball of making sure that as the app grows and things that you've caught up with the changes. And so the biggest thing would be reformatting that data, and that's where our wonderful partner solutions come in and really help us out. Tarun, with Mongo, what MongoDB releases does Rubrik Datos IO support?
Thanks, Doug. Thanks for fielding all these questions. We support MongoDB 3.2, 3.4, and 3.6, all those three versions. We also support 3.0, but as you all may know, 3.0 also had an mmap version along with WireTiger, but 3.2 onwards is only WireTiger. With our latest release and releases going forward, today we will support 3.0, but in future going forward, we won't be supporting 3.0. We'll be only 3.2, 3.4, 3.6, and beyond, which is MongoDB 4.0, which we don't support today, which we will in the second half.
Awesome, perfect. Thank you guys for all of your patience in answering those questions for us. And as we close to the end of the hour here, just in closing, we have a slide here with some next steps. Different links. So the slides will be sent out, so you have the links available to you. And I just really want to thank everybody for attending today's webinar. Thanks to Arun and Brian for coming on and taking the time to speak with us. It's tough to block an entire hour out of your day. Please remember to stay connected and complete the brief survey at the conclusion. And we look forward to supporting you in current and future projects. And thank everybody again, and have a great day.